Hello everyone, and welcome back to the engine history. A cast iron lump left outdoors for 40 straight years, soaked in dew and eaten alive by rust, can seize the entire top end solid. Can a mechanic tear it down, press in new sleeves, and restore combustion chamber pressure to factory spec? Today, the team hauls a Ferguson TEA-20 tractor onto the test stand, cast in 1948, a model many in the trade call the Little Gray. This is not a showy, painted up and fool people build. This is a real problem of cutting through rust, rescuing the head surface, setting bearing clearances, and retorquing every bolt so this block of iron can do real field work. When you receive an engine that has been clinically dead since the middle of the last century, you do not rush to pull bolts. You inspect the material condition first. The TEA-20 engine block and chassis use a shared load-bearing design. That means the engine block is cast together with the gearbox housing to form the main backbone that carries the load for the entire tractor. That is why the block is cast in extremely thick gray iron. However, rust at the water jacket connections forces the mechanic to use industrial cleaning chemicals and dedicated gasket scraper tools to avoid scratching the machine surfaces. Looking at the configuration, this machine uses a standard motor company inline 4-cylinder water-cooled engine. The valve train uses overhead valves with the camshaft mounted low inside the block. The compression ratio is kept very low, around 5.7 to 6.0 to 1. This setup lets the engine swallow low-octane fuel from that era without knocking or hammering the valve train. Before the team lifts the block for machining, measures ring end gaps, and sets valve lash, if you love torque specs and old engine assembly tolerances, subscribe to the Engine History. Turn on the bell so you can follow these teardown cases from compression to combustion. Support from you helps the team hunt down more technical documentation for deep engine work. Once the cylinder head comes off, the problem shows itself immediately. Moisture has entered through the intake and exhaust ports, rusting the cylinder walls and locking the piston rings in their grooves. The mechanic must soak the cylinders in rust-dissolving chemicals for multiple days. They also use mechanical pullers to press the pistons free to avoid cracking the cylinder walls. With the block fully stripped, the mechanic brings out a micrometer and a dial indicator to measure bore taper and out of round. If cylinder wear exceeds tolerance, the block must be bored oversize and matched with oversized pistons. To seal compression and hold oil, the mechanic must hone the cylinder walls. The hone creates a cross-hatch finish that retains an ultra-thin oil film as the piston slams up and down at speed, preventing bearing wipe and rod damage. Down at the crankshaft, the main journals and rod journals are checked under tight clearance rules using plastigage. The connecting rod bearings and main bearings are replaced entirely. The critical move at this step is tightening the rod caps and main caps correctly. A torque wrench must be used to hit the manufacturer's specified torque values. Over-torque will distort the bearings and seize the crankshaft. Under-torque can let a cap loosen and spin a bearing when the engine is under load. After the torque is set, the mechanic should be able to turn the crank by hand smoothly, with end play sitting inside the correct specification window. The real money feature of the TEA-20 is not only the engine block. It is the 3-point linkage integrated with a hydraulic pump built directly into the transmission. This mechanical plus hydraulic system automatically senses draft load from the soil and adjusts implement depth. When the plow hits hard clay and draft load spikes, that force pushes back through the A-frame arms, compresses a spring, and moves the control valve inside the pump assembly. The pump instantly drives pressurized hydraulic oil into the lift cylinder. It raises the implement by a few millimeters to relieve load, while also transferring more weight onto the rear axle to reduce wheel slip. This 4-piston pump is driven directly off the transmission power path. To service it, the mechanic must drain contaminated oil, press in new rubber seals, and clean the relief valve so the system does not bleed pressure when lifting a heavy load. As for the gearbox, this tractor uses a 4-forward, 1-reverse manual transmission. The gear train is a mix of helical and straight-cut gears. The tapered roller bearings in the driveline and the differential must be pulled, cleaned, fitted with new bearings, and then reset. Ring and pinion mesh and backlash must be adjusted to eliminate gear howl when the tractor is pulling hard. Moving to the fuel system, the Zenith downdraft carburetor is stripped completely clean. Clogged jets and passages packed with stale fuel residue are soaked in chemicals and cleaned in an ultrasonic bath to knock out rust and deposits. Float height is measured and set precisely to lock fuel level in the bowl. That prevents flooding and bogging when the tractor is crawling across hillsides under load. Working with the carburetor is the centrifugal governor that controls the throttle butterfly. When load bites and RPM drops, the governor automatically opens the throttle to feed more mixture and hold engine speed steady. The TEA-20 ignition system uses a distributor with mechanical breaker points. The mechanic sands the points clean, uses a feeler gauge to set the correct gap, then rotates the distributor to set ignition advance. The spark must fire at the correct moment as the piston approaches top dead center on compression, so peak cylinder pressure hits at the right time. Correct timing is the final lock that lets the combustion chamber deliver maximum compression power. Installing the head is the most stressful part. The head gasket, whether steel, asbestos composite, or copper, must be aligned perfectly with the passages. Head bolts must be tightened in a spiral pattern from the center outward. Torque is applied in 3 increasing stages, so the head seats evenly on the block, with 0 warping allowed. Valve lash must be set with the engine completely cold, leaving room for metal expansion at operating temperature. Heavy-duty engine oil is poured into the sump. Power is fed to the starter, and the starter pinion engages the flywheel ring gear to crank the engine through its first turns. The mechanical oil pump pulls oil from the pan, forces it through the filter, and drives it up into the cam and rocker gear and into the crank journals. After only a few compression strokes, the mixture lights and the block snaps alive with crisp firing. The mechanic immediately checks the oil pressure gauge. The needle jumps up and holds steady, proving the oil film is fully established under pressure. Idle is firm and confident. The exhaust does not blow blue smoke. The breather does not puff hard, blow back out. That confirms the rings and valve faces are sealing compression properly. After letting the engine run and wear in the clearances at idle, the Ferguson TEA-20 is dragged out to the field for a real load test. The clutch engages cleanly and decisively. The gearbox shifts smoothly without grinding. The PTO spins hard, sending torque out to the implement behind. Putting an 80-year-old cast iron block under real maximum load proves the core truth of old engine casting. Solid metal, assembled to correct specification with full oil pressure, will work until it wears out, not until it dies on the road. Thank you for staying with this teardown analysis on the engine history. Goodbye, everyone, and see you again in the next engine teardown case.